Hello! Today we're going to go over section 4.4, which is how to find inverses. So first we're going to start off kind of with easier ones, and that is if you have an ordered pair. If we have an ordered pair or a relationship that pairs an element A to an element B, like this, where we have our x value is A and our y value is B, the inverse is going to do the opposite thing of that. So if AB is an ordered pair of a relationship, then BA is going to be the ordered pair of the inverse. So if both a relationship and its inverse happen to be functions, then we consider them inverse functions. So the inverse of a function may or may not be a function. Let's actually just remember what it means to be a function before we keep talking about it. A function is a very specific definition. What it says is that for each x value that you have, it only goes to one y value. You might remember making these mapping diagrams in middle school where you would draw the little arrows. So we can have one x value going to one y value, and it's okay if these x values share the same y, but the problem is if we switch it, we can't have one x value going to two y's. The reason being is if I drew this, and let's say I'm at 1 for x, I'm over 1, and then they're saying I'm up 1.2 for 1 point, but then they're saying I'm up over 1 and then up 1.4 for another point. So I would have these 2 points right here, and if you remember in middle school, you probably learned the vertical line test, that if I draw a line vertically, I can't cross 2 times, which is what is happening here, where we have one x value, we're over 1 for x, but it's hitting at 2 y values, and that's where we have a problem. And so that would be not a function. So this is okay where we just have one arrow going to one thing, but if I have one x value with 2 arrows coming out, that's where it's no longer a function. So sometimes when you take the inverse of something, because essentially when you do the inverse, all you're doing is switching the x and y's. Well, when I do that, my function is no longer a function. So that can happen sometimes. So this little diagram here, this would be considered a function, but this one would not be a function. So some of the questions you'll get on your homework will just be tables like this. They're super easy to find the inverse of because you literally just flip the columns. Your x column, your domain column becomes your range column, and your range becomes your domain. So super easy. You just flip their places. The domain goes to the range, and the range goes to the domain. Okay, let's look at some other examples you might see. So on this one, they want to know what are the graphs of the function t and its inverse. So here's a table of values right here for function t or relationship t. So if it's an xy table, these are going to be your points. So let's go graph that really quick. Here's my axis. So I have a point 0, -5. So over 0, down 1, 2, 3, 4, 5. And then I have a point at 1, -4. So over 1, down 4. And then 2, -3. So over 2, down 3. And then over 3, down -3. Okay, so there would be, have this little shape right here, these points. So that would be function t, but now they want to know what is the inverse of t. So if I make my little xy table, again, all you're doing is you're switching the columns places. So my x's are going to now be my y's. So 0, 1, 2, 3. And my y's are going to be my x's. And so then if I go graph this set of ordered pairs, now I have a point at -5, 0. So I'm back 5 over 0. Then I have a point at -4, 1. So over, back 4, up 1. And then we have a point at -3, 2. And then we have another point at -3, 3. And so here was our original function. This is t, and this is t inverse. And the notation we do for an inverse is we put a little -1 exponent on it. So that's going to be how I show this is t, and then this is t inverse with that little -1 exponent. Something else you can kind of notice in this graph is, do you see how they're kind of reflections of each other? They're not kind of reflections, they are reflections. An inverse is going to reflect on this diagonal right here along this line y equals x. So it's just a slope of over 1, up 1, over 1, up 1, over 1, up 1. So this reflection goes across that line right there, and that's kind of another way you can tell that it is an inverse. So now they're saying, if this is a t, our original relationship, is it a function? So again, if you have a graph, a really fast way is just to check, does it pass the vertical line test? If I draw vertical lines through, do I ever cross more than once? Which on this one, I don't. So is t a function? Yes, it is. I only cross one time. But is the inverse of t a function? So if I draw my little vertical lines, here we see we have that problem again where I'm crossing 2 points at once. So that is a no. We can only have one x value for every y value, and this one has one x value, has two y values. So it's no longer a function. So in that problem, those graphs show an inverse, and that they're reflections of each other along the line y equals x. So if you describe a relation or a function by that equation in x and y, we just switch these columns places, right? The x's and y's just switched. And so if we want to do that for an actual equation versus the graphs or the points that we were looking at, we're going to do the exact same thing. We're going to switch x and y. So when they give you an equation, it says what is the inverse of y equals 2x plus 8, the first thing you're going to do is you're going to switch x and y's place. So if this is where my y is and this is where my x is, I'm literally going to switch them. I'm going to have x equals 2y plus 8. And then from there, what you're going to do is we're just going to start back solving to get y alone again. So if I want to get y by itself, I need to get rid of this 2, and I need to get rid of this plus 8. So the order does matter here. I have to get rid of the plus 8 before I can get rid of that 2. So to get rid of a plus 8, we're going to subtract 8 from both sides so that I have x subtract 8. Those cancel, and I get 2y on this side. And then now to get rid of the 2, we're going to divide by 2. And we'll divide everything over here by 2, and those cancel. So we get y equals x minus 8 divided by 2. And again, the notation you're going to start seeing is this is the equation or the function y. So to show that this is the inverse of y, we put this little -1 exponent on it, just to show that y is different from y inverse. And when you're looking at these equations, they should look like inverses of each other. On this original one, it was being multiplied by 2. Well, now we're dividing by 2. Those are opposites. Here we were adding 8, now we're subtracting 8. Again, they should kind of look like opposites that way. Let's practice some more. So let's find the inverse of these functions. So we have y equals 4 minus 3x. So again, that first step is you're just going to switch the place of the x and the y. And then from there, you're just going to try and get y alone. So first I'm going to minus this 4 over. So I have x minus 4 equals a -3y. And then to get rid of that -3, we'll divide by -3. And those cancel. And so then we get y inverse equals x minus 4 divided by a -3. Or if you wanted to, if you don't like that being a -3, you can divide that negative through, which will just switch the signs out of everything. So you could write this also as -x plus 4 over +3. Or if you don't like that -x being there, you can also switch the 4 in the x places and do 4 minus x over 3. There's a few different ways you could write that one. But again, they should look like opposites of each other. Here we had a +4 minus 3x. Now I'm dividing by 3 and subtracting 4. So, okay, let's try a little bit more difficult of one. have some more stuff going on here, but still the same steps are going to apply. We're going to switch the place of the x and the y. So I get x equals 1 minus 2y squared plus 5. And again, once we switch those places, we're just trying to get y alone. So on this one, we do have more steps to do since there's more things to get rid of. So think of that order. I can't touch anything in here until this 5 is gone, so that has to be my first step. So let's subtract the 5 over. And I get x minus 5 equals 1 minus 2y squared. And then now I can't get inside of here until this square is gone. So the how we get rid of a square is by square rooting. So I'm going to take the square root of each side. This square root cancels with the square. And we are left with, I'm going to come over here, the square root of x minus 5 equals 1 subtract 2y. And then now, still just trying to get y alone, I have to get rid of this 1 before I can get rid of that 2. So let's subtract the 1 over. Whenever you have these square roots, make sure you're being careful with how you write it. Right now, the minus 5 is underneath that square root, but when I subtract this 1 over, it's going to not be under the square root. So just be careful with how you draw that line and don't extend it too far. Then that will equal negative 2y over here since those cancel. And now I can get rid of that negative 2 by dividing. Remember, these are being multiplied. Sometimes when there's that negative there, I get students trying to add 2 over, but it's negative 2 times y. So to get rid of that times, we need to divide. So I'm going to divide that whole thing by negative 2. And that does look kind of messy. You can write it this way, which again is kind of an ugly fraction. Or you can, instead of dividing by a negative 2, dividing by a negative 2 is the same as timesing by a negative 1/2. So I could also write it this way, where I have that negative 1/2 times the square root of x minus 5, subtract 1. And that will equal your inverse. So you can write it this way or you can write it this way. Either answer is fine. It's just kind of a personal preference of how you like to deal with it because it is kind of an ugly equation. Okay, so that is how you do that. On this one, they want us to graph each relation and then find its inverse and graph the inverse. So here we have y equals 3 minus 7x. This is just a line. It's the same as y equals mx plus b. Hopefully you guys remember that little formula from middle school, where m is your slope and b is your y-intercept. Ours is just flipped, but that's the same as negative 7x plus 3, so you can think of it that way. So that means our slope is negative 7, that's our m, and b is 3. So if I go and put my axis on, here's our x-axis, our y-intercept is at 3, so 1, 2, 3. And our slope is a negative 7, so you can think of that as negative 7 over 1. So think of that again as your rise over your run. We're going down 7, 5, 6, 7, and then over 1. So I'm only going to be able to fit 1 on here. So this is a really steep line. And then connect your dots. Oh, that was a really bad connection. There we go. A little better. And then now they want us to do the inverse. So here's our original graph. Let's find the inverse first. So we'll need to switch our x and y. So I'm going to have x equals 3 minus 7y. And then start solving back for y. So let's minus 3 over first. We get x minus 3 equals a negative 7y. And then divide by negative 7. Those cancel. So here would be our new inverse. I do think when you're graphing it, written this way is a little bit complicated. So let's think of this as being x over negative 7 is the same as negative 1/7 x. That way we can think of that as our slope, our rise over our run. And then we have negative 3 over negative 7 would turn to a positive 3 over 7. So now we have our mx plus b format, and that will just be a little bit easier to graph by hand. So if this is our slope, that's our intercept. 3/7, that's like about 1/2, so we can kind of fudge it. We'll just say it's about right there. And then our new slope is negative 1/7. So that means I'm going down 1 over 7. 1, 2, 3, 4, 5. I'm just going to kind of make it up. 6, 7. Be about right there. And then if we reversed it, I don't think I have enough going back either. It'd be up 1 and back 2, 3, 4, 5, 6, 7. About right there. And so then if I kind of connect those, not very good. There's our graph. And so again, these do reflect across that line. My graph's not perfect because I'm not a very good artist, but you can kind of see how they're a reflection of each other. For sake of time, we're just going to do that one for the graphing, so I'm going to skip that next one. But again, when we do our inverse notation, the inverse of a function is shown by this little notation right here where you do your variable to the -1 power. So we would read that as the inverse of f, or f inverse. So this notation is just kind of help us know what we're talking about. It doesn't actually mean to take an exponent of -1. So when you're given something like this in the function notation, g of x, it's still the same steps as when we were doing it with y up above. You can even change it to a y if you want. Sometimes I do that instead of using g of x. So I'm going to just write this as y. That way I know I still need to switch the x and the y when I do that, rather than use the g of x. The only thing is when you write your answer, you will need to go back and write it as g to the -1 to show that it's the inverse. But I do think it is easier to use y when you're going through. So on this one, they said g of x is 6 minus 4x, or you can again think of that as y. And they want to know what is the domain and range. Well, 6 minus 4x, that's just a line. Or you could think that's -4x plus 6, where you have your slope and your y-intercept. So the domain and range of a line, no matter what the line looks like, is still just going to be from -infinity to +infinity. A line just keeps going forever and ever. Same with the range. It's just going to keep going up and down forever and ever. So that's kind of an easy one. So now they want us to find the inverse. Again, rather than doing g of x, I do think it's easier to write y equals 6 minus 4x. So just switch it. And then we're going to switch the x and the y place. And then start solving for y. So first, let's minus the 6 over. So we get x subtract 6 equals -4y. And then divide by -4. So those cancel. So then here is where we would switch back instead of using y. Since they started with g of x, we need to write our answer using g of x as well. But to show that it's the inverse, you're going to do that little -1 exponent. So that would just mean the inverse of g. And so again, you can keep it this way where you do x minus 6 over -4. Or if you want, you can write that as a fraction out front. That's the same as -1/4 times x minus 6. It's just kind of personal preference on how you want to write that. I'm not picky on how you do it. And then we still just have a line here. So the domain and range of our inverse equation is still just going to be -infinity for the domain to +infinity, and the range is also -infinity to +infinity. So when they're asking you about domain and range, this one's kind of a bad example because the domain and range are the same. Whenever we're doing an inverse, the whole premise of this is we're switching our x's and our y's places. Remember, x's and y's are domains and ranges. So really what you'll see happen, and again, this was kind of a bad example because they're exactly the same, is your domain becomes your range and your range will become your domain. This was just not a very good example since they're just lines and it just goes from -infinity to +infinity both directions. But if you have a more complicated example, you'll see that that domain becomes the range and that range becomes a domain. Again, that whole idea is x becomes y and y becomes x. So let's try a couple more. I think we'll be done for today. Just want to make sure we feel okay with some more complicated ones. Whenever you have that function again, just switch it to a y just to make your life easier. And then we'll just do the same steps, switch x and y's place, so that we have x equals the square root of y plus 7, and then start solving for y. So I can't get to this plus 7 while that square root is there, so to get rid of a square root, you have to square. So square both sides, and that square and square root cancel with each other, so that I have x squared equals y plus 7. And then now we can minus that 7 over. And so we get x squared minus 7 equals y. But again, they started with f of x. So I know it's being really picky, but we need to switch back to f of x. However, now it's the inverse. So we're going to do that little -1 on there. And so we're saying the inverse of f equals x squared minus 7. And again, you should be able to kind of visually see that these are opposites of each other. We have a square root and a square. We have a plus 7, we have a minus 7, so they look like opposites as well. And then let's just do this last one. I'm going to switch this to a y first. And then we're going to switch these places so that I have x equals 2y squared plus 2. And then start solving for y. So let's get rid of this plus 2 by subtracting it. So I have x subtract 2 equals 2y squared. Now I need to get rid of this 2 before I can get rid of that square. So let's divide by 2 first. And then I have x minus 2 over 2 equals y squared. To get rid of that square, now I'm going to take the square root. So replacing the y back with a f, we're going to say the inverse of f, so use that little notation that we're learning, equals the square root of x subtract 2 over 2. And that would be your answer. So not very pretty, but that's what it is. Okay. And then I think we'll stop there. There's some story problems on here, but I don't want to worry too much about those on this video. So we'll just stop there. So again, the whole idea of inverses is that you are switching your x's and y's. That's the whole idea. Whether it is the table format, you switch your x and y tables. If it's an ordered pair, you're going to switch your x and y ordered pairs. If it's an equation, you're going to literally switch the x and y place and work backwards. So that's the whole idea of inverses, is that they're opposites, so you're switching the x and y's place. Hopefully you guys are feeling good with that. Please let me know if you have any questions. Shoot me an email and we can set up a time to get together and work over your questions. Hope you guys are staying safe and healthy, and I will talk to you later. See ya.